So let's now continue with the advanced functions charts. For example, now we are going to discuss about how to create CDF, Cumulative Distribution Function. Okay, as you can see here, I have two figures. The one on the left showing the CDF between band N1, FDD N1, and band TDD N78, which is FDD like in term of coverage differences, RSRB. So first of all, let me recall what it means by the distribution function and what is the like cumulative distribution function and what is the like use cases we can use it for this chart, which I believe it's one of the most important in terms of many things. So let me just put this one in the focus mode. So assume now you have a drive test, complete drive test, which is showing these two carriers, and they would like to compare the coverage. So usually we do it like even to visualize through the coverage plot, or even to take the average value of absolute variable. But actually, if you can see this figure, it's giving a very clear figure of the differences between both bands in terms of coverage point of view. Why? Because in general, cumulative distribution function gives you the probability that a random value takes a value less than or equal to a specific point. What it means by this? For example, if you can see our x-axis here is consisting of the coverage starting point, for example, from 105 RSRP till NIC 51. So in each single point, you can see the differences. So now if you want to, for example, the point 50 here. So at this point 50, it's telling you that at level of NIC 79, if you click here again, at level of NIC 79, the N1 band having around 38% of the samples less than or worse than minus 79, while N78 having around 50% of the samples, which indicates that N1 is far beyond. And also as absolute average, you can even get it from the same point of view. Like for example, here it's showing that N78, line of N78 showing minus, while this one showing minus 76. So at this particular point, we have around 3 dBm differences. And if you went above here, it's NIC 73, for example, for N78, which is dark blue. And for this one, it's around NIC 68. So it's around even 5 to 6 dBm difference in the coverage. So this is like, if you can see the light blue here, is showing that there is a good variation in the coverage between N1 and N78, which is actually very important in terms of coverage comparison, even benchmark. Like for example, if you did a benchmark and you want to show a clear benchmark between, for example, the pre and post, or all other stuff, even throughput or whatever. So it's like actually it's like a running total running total of probabilities up to a certain value, and this certain value depends on your raw data. So it's just a quick explanation about the CDF. Now let's discuss how to create it. It's kind of actually how say it, it's need a DAX or DAX. Actually, DAX. Whenever I mention DAX, DAX is the language used by Power BI, which is like used for the calculation of the formal calculation. So actually, it can be created in 3 steps. So now let's try to generate one of these and quickly. So first step you need to use line chart. As you can see here in the top right, you need to use line chart. So I will create one line chart. Okay. So now I'm going to use the same raw data for this one. This raw data actually, if you check here, it's consisting of like in our coverage, it's having the band, which is N1 and 78, then the date of the drive test, then you have the NR serving RSRP. You have the equivalent RSRP for both of them. The other two I have created to create this one. So this was the first step to have the line chart. Now the second step, now you need to drop the coverage into the x-axis. So this is the main point. So you will take this one and drop it here. So actually in this particular case, in Power BI, you need to create bins. So what it means by bins, you need to right click here, double click, left click here, then you will find this new group. So you need to click new group. So you will convert this x-axis into bins. You can choose a bin size even to 1 dBm, for example, or 1.4. This is automatic came by the system. So initially I will just give 1 dBm. Means what? That it will, for example, move from 105 to 104, 105, 106, and so on. Like this will be the stepwise as 1 dBm. So now if I click it, now I have created the bins. And the bin size which I have created, it's called N serving RSRB bins. Here it came here, it's already created here. This can be changed. For example, you can double click and change it to whatever you want. Like for example, I will call it NR RSRB bins 2 or bins only. Okay, like that. So now, and the most important point that whenever you need to change the stepwise, you just need to right click here, then just make edit groups. Okay, so once you edit group, you can change the stepwise. So now going back to this one, now we have created the bins. What is the second part we have to do? Actually, usually what we need to do, you need to calculate the running total, right? Like how many samples at each bins and the percentage of this samples. For example, at this particular area, NIG 87, the samples of N71 was around 30.77, and it will increase whenever you are moving for each and every single samples. So this means that at this NIG 83, it's counting how many samples for NIG 83, then it divided by the total samples of the RSRB coverage of N1. So for example, here, if I drag and drop this one here, it will be like showing like this figure, and this is like taking the count. So now it will be showing like this. So now it looks like the histogram or whatever. This looks like the histogram. So now I need to convert it into CDF like this one. So each point, for example, this one should be divided by the total number of samples, right? So now in this case, we need to create a DAX formula. So I will just right click here as we mentioned before. First of all, let me remove this. I right click here and you have the new measure. And again, to recall whatever I mentioned, once you click in the table, you will find this table tools. You can make a new measure to create a DAX, or you can even click here, right click, just to choose the location of this DAX. If you right click here, for example, it will be created here. It can be created anywhere. So now I will just right click here and make a new measure. And this formula I will be adding into the video description, because maybe in the beginning you will be struggling to understand it. So you just keep it with you reference whenever you need to create a DAX until you understand it in details. So now this is how we create the DAX. So now we have the measure. I will call it CDF, coverage RSRB CDF. Then the first point we have mentioned, we need to calculate the total sample. So this actually use a calculate formula. So this calculate formula is asking you for the expression, what you would like to do. I would like to calculate first the count, right, of RSRB samples of the data set. My data set name is NR coverage benchmark, which is serving RSRB. So I will choose this one. Once you have done this one, you need to close this. Then now I need to calculate the samples, then divided by the total samples. So I need to calculate the samples, for example, for band N1 at this particular area. So you need to give a filter to look into, first of all, the bins, and the bins like bins wise, and also to look into the filter which you are applying in your chart. So I will just make a filter here, and inside this filter, I will use another formula called all selected. And the idea of all selected, this one, that whenever I apply any filter within the chart, it will be applied if I didn't use all selected and I use only filter thing. So it will not consider the filter. So if I'm giving, for example, a legend here, which is N1 and 78, it will not show accurate results. See this one, what's saying? Return all the rows in a table or the values in a column, ignoring any filter that might have been applied inside the query, but keeping filters that come from outside. This is actually like the filters which from outside, which is here. That's why I'm using this part. So simply this one, I will give now the bins which I have created, which is called the number of bins which I needed, the data set which I created below down here, if you remember, in the RSRB bins. So this one will be data set in the RSRB data set one, sorry, in our coverage benchmark, this one. So now I have selected, this should be not one, I'm using the bins and normal bins. So I will remove this one, it will be this one. Okay, so now this is the first thing. Now I need to calculate for each bend, right? So if I'm here, I need to calculate the total count from here till the beginning, right? So at this particular area. So what I have to do, I have to do first telling him if the bends wise, which is my bends, this one, is less than or equal the maximum of bends. Again, I will take the same one because I'm comparing to. So I'm telling him, please calculate the count here for starting from this particular point till the end of here. This is just to calculate the count. So now I'll close this one and this and this. Now I need to divide it by the total count, ignoring like this kind of total count of bins, I mean. So now to be calculated, then again, if you let me take down here just to make it more clear. So now I'm dividing by the calculate, again, the count of total RSRB, which is this one. Okay, then I will make comma. The filter wise will be now all function, This is all functions saying why return all rows in a table or all the values in a column, ignoring any filters. I don't want any filters. I just want to return this total count without considering any feature. Total count of the bins, I mean. So I will give the bins formula here. So now the bins column. So now once I have done this, now I will do like this. Now it's being calculated here. I will remove this one and I will drag and drop this one here. See now, this is how it's giving me. It's like, it can be percentage. You can just click here and change. Once you click here to add measure tool, because this is a measure, that's one measuring tool. So you can just change the format, for example, to percentage. Okay. So now we have it calculated. So now, for example, I need to take the band and drag and drop it here in the legend. So now you can see it's giving me similar. And about the formatting thing that we have above, I will discuss it in separate. So this is actually how we calculate the CDF. This can be worked at any stuff you are doing. But the main idea that I'm telling you that it calculates all the count of the bins at each point, like starting from this point till the end, then it divided by the total samples of total bins just to calculate this total running in terms of percentage. So this is actually what we can do for the CDF point of view. As I'm telling you, I'll drop the formula because in the beginning it will be like looks complicated. So I'll drop it until you understand it and until we go for the DAX, so it will make it more clear for you.